In the next two lessons we're going to look at expansion in fluids. In this lesson we're going to look at expansion in liquids, and in the next lesson at expansion in gases. So imagine here we've got a liquid, we've got particles which are quite close together and they are bound by weak attractive forces which allow the particles to move from one place to another randomly throughout the structure of the liquid. Okay, so what happens when we heat the liquid? Okay, so what happens is that some of this heat energy will be transferred to the kinetic energy of the particles in the liquid. As a result of that, the particles will move faster and they will expand like this. Okay, so you can see as a result of the increase in movement of the particles, then there is a small expansion of the liquid. We looked at the analogy in the last lesson of people on a dance floor. Okay, at the moment they're stationary, they're quite close together, and you turn up the music, then they start dancing and moving around, and they will inevitably occupy a larger area. Well, again, the same applies to particles in a liquid, except that they are moving in 3 dimensions and will therefore occupy larger volumes. And just like solids, the expansion in a liquid isn't really very large compared to the expansion, for example, in a gas. And we'll look at the reason for that in the next lesson. What we can do here, though, is we can make use of this property to devise an apparatus which will help us to measure temperature. Okay? As you will know, these devices are called thermometers, and they basically consist of a bulb with a liquid. Now, the liquid traditionally is mercury, but mercury is deemed, for example, particularly in schools, as being a potentially hazardous liquid, particularly if a thermometer is dropped and it spills on the floor. And as you know, mercury is a toxic liquid, so you don't really want that hanging around. Many schools now use alcohol-based thermometers, but from our point of view, that doesn't really matter. What we have here are liquids. When the temperature surrounding the thermometer bulb increases, heat will flow into the bulb, causing the liquid inside the bulb to expand. And as it does so, it will expand up a narrow capillary tube. Let's just label that. So we've got the bulb, and then up here we've got the capillary tube. Okay, so this small expansion of the liquid is manifest in this very narrow capillary tube, which can be graduated and so can be used to measure temperature. Likewise, if the temperature around the thermometer bulb cools, okay, heat will then flow from the bulb to the outside and the liquid will contract. As a result, the level of the thermometer will fall as the volume of the liquid decreases.